Good morning, everybody. So today we're going to continue on with our little introduction and exploration of dimensional analysis. So last class, we were using this unit conversion process to convert familiar measurements. So stuff like centimeters to meters, kilometers, so on and so on. So today what we're going to use is the same process in a chemistry context. So what we're going to do is we're going to convert the mass of a substance into a mole of a substance. So if you recall what we've been talking about the last few days, chemists cannot count atoms for two reasons. They're too small and you need far too many of them. So that particular chemist needs to be able to count atoms using mass. And in order to facilitate this process, the unit mole was created. So if you remember back to our little discussion here on 926, oops, 926. We go down here. Avogadro's number was utilized as the standard for 1 mole. So 1 mole of any substance is equal to 6.02 times 10 to the 23 individual units of that. It could be anything. You could have 1 mole of atoms. You could have 1 mole of elephants. It doesn't matter what you have. It just means you have this number of those. And we also had a second definition of a mole, and that was that 1 mole of an element is equal to the mass, the molar mass of that substance. So these numbers here on the periodic table, these decimal numbers on the bottom, are the mass of 6.02 times 10 to the 23 individual atoms of that elemental compound. So, for example, if I wanted 1 mole of fluorine, if I wanted 6.02 times 10 to the 23 atoms of fluorine, I would just go to a balance and mass out 18.998 grams. So, where that number came from is not important right now, but that's what these numbers are. So, anytime we need a chemical substance, we need to measure out a chemical substance, we come to the periodic table and we get the mass of that substance. We can then use that mass in our conversion factor. So our conversion factor would be 1 mole of the element. So here, 1 mole of chlorine over 35.45 grams, right? So we're generally not going to need 1 mole because 1 mole of a substance is a huge number of atoms. And in our little chemistry labs, we don't use anywhere near that quantity of stuff. So we're always going to need to know a mass number. And this is what we're going to use our conversion process for. So our warm up today is going back to this. I'm still waiting on answers to these questions here. So we're going to give it another shot. Okay, then our activity is going to be to use our molar conversion steps. So again, here are the steps on unit conversion problems. So here I have notes so I've taken the step-by-step process and I've specifically asked myself a question involving moles and grams. So here it's the same process. Instead of using metric system measurements in my example, though, or whatever it is, I'm using grams and actual moles. So you can see here the steps end up being the same. But I put that here. Here's a lecture video again over this. So if you want to look at that at home or whatever, it's the review video there. And then here's the practice sheet that we're going to be using. So we're going to be using this sheet. So again, you go over into our assignment folder and you'll find this. So we go into Teams. Here's our assignment here. So you'll find the step-by-step problem. So again, there's the step-by-step notes. Here's the sheet, and then here's our response workbook. So we just enter the responses into there. Okay, so our exit ticket then is going to be a little learning check over dimensional analysis and molar conversions. So we have a couple questions over that. And again, you'll find that in the assignment tab. So that's today.